This is the third video in the Library of Functions video. Today we're going to be talking about some other types of functions. The first one is the square root function. It's a function of the form f of x equals the square root of x. This graph is a curve that begins at the origin and then proceeds into quadrant 1. The properties of this function, the domain. The domain for this function must start at 0, including 0, and go to infinity. So it's all real numbers that are greater than or equal to 0. We cannot put negative numbers in for x because in the real number system we can't take the square root of a negative number. So only 0 and positive x's are allowed to go into this function. The range of this function is also all real numbers that are greater than or equal to 0. This function continues to go up and up and up and up and up further. We can't have any negative numbers come out of this function because this is the principal square root, and when we take the principal square root of a number, it will always give us either 0 or a positive number. This function is increasing over its whole domain, so from 0 to infinity. The y's, as you look at this function from left to right, the y's increase. It does not decrease at all. And its x-intercept and y-intercept are both the origin. The next function is the reciprocal function. It's a function of the form f of x equals 1 divided by x. The graph of the reciprocal function is a curve that is in quadrant 1 and quadrant 3. It has two branches. It approaches the x-axis and it approaches the y-axis, but it does not touch either of them. If you look at the branch that's in quadrant 3, you can see that this branch will approach the x-axis, get closer and closer and closer to it, but never touch it. It will also approach the y-axis, but never touch it. The same thing happens with the branch in quadrant 1. It gets closer and closer to the y-axis, and it gets closer and closer to the x-axis, but never touches it. These lines that the graph approaches but never touches, that's called an asymptote. You probably will remember that word from Algebra 2. The properties of the reciprocal function are the domain has two parts because there are two branches here. So the interval from negative infinity to 0, we cannot include 0 because this function will never assume a value of 0 for the x, and that's because we cannot divide by 0. So we have to skip over that value of 0 for x and then begin to pick up the numbers again, so from 0 to infinity. This symbol is the union symbol. It means that we're going to put these two intervals together to form the whole domain. But we've had to skip over something, and in this case, the something that we skipped over was the 0. The range looks the same. We're looking at the y values now, though, so we can have all of these y values down here, but when we get to the y value of 0, we can't use it because the two branches of this function will approach the y value of 0 but never touch it. Then we can use all the positive y values. This function is not increasing at all. It decreases over its whole domain. When I start on the left and move to the right, the values of the y are getting smaller and smaller and smaller. Then when we skip over the x of 0, my y values continue to get smaller and smaller and smaller. So it does not increase at all, it only decreases. There is no x-intercept here because this function never touches the x-axis. There is no y-intercept because this function never touches the y-axis. The next function we're going to look at is the absolute value function. It's the function of the form f of x equals the absolute value of x. The graph of the absolute value function is a V-shaped graph, and it will go through the origin, and it is in quadrant 1 and quadrant 2. The properties of the absolute value function are the domain is all real numbers, and the range is any number that is greater than or equal to 0. So from 0 inclusive to infinity. It is decreasing on the interval from negative infinity to 0, and it is increasing on the interval from 0 to infinity. It has an x-intercept of the origin, which is the point 0, 0, and a y-intercept of the origin, the point 0, 0.